All right, so I'm going to go back to my antimicrobials handout. I'm sorry it took me a moment to find it. And we can go ahead and take a look at this. Your synthetic antibacterial agents. Well, you know what? Let me back up because I don't think we talked about broad spectrum and narrow spectrum drugs. So I'm sorry, we missed that. Antimicrobial spectrums are the range of antimicrobial drug action. Some drugs we have learned are broad spectrum antibiotics. Therefore, whenever you're taking them, you will be treated for a number of different possible species of microbes. Those are great whenever you don't really know the specific bacterium or maybe even a fungus that may be causing the disease. So therefore, they'll just give you something that's probably going to kill whatever it is, which is actually quite common anymore. Because otherwise you'd have to go through a test, and the doctor would first test you for strep or certain specific bacterium to be able to give you a very specific drug that would therefore be more narrow spectrum. This is, and I'm going to go ahead and show you the chart on page 299. That is very handy for understanding the different antimicrobials and their spectrums. This is going to focus on the actual spectrum of activity of selected antimicrobial drugs. This is figure 10.8 in your textbook, page 299. We have to remember that some of these are going to be broader spectrum than others. So, for example, a good broad spectrum antibacterial, or one that focuses on prokaryotic organisms, would be erythromycin, tetracycline, sulfonamides. You notice those at the bottom of this chart, how they spread across gram-negative, gram-positive bacteria, and as well as chlamydias and rickettsias. When we get into bacteria, that's kind of the way we split them up. Sulfonamides will even cover certain types of eukaryotic organisms as well, such as certain types of protists. Polymyxin is a very common drug. Actually, it's a little more common usage with fungus, so we'll talk about that when we get into certain types of fungi. Penicillin is great for gram-positive primarily. We do have some semi-synthetics of penicillin that are a little broader acting agents that will work for both gram-positive and some gram-negative bacteria. Streptomycin, great for gram-negative as well as certain types of mycobacteria. Isoniazid is a very specialized, very narrow spectrum drug, as you notice, for a specific type of bacterium that is headed under the category of mycobacteria. I'm not really looking at the eukaryotes or the viruses right now, but there's your list of specific drugs that will treat those types of organisms. Helminths, what those are is basically your parasitic worms. That's what a helminth is. Praziquantel, niclosamide are great drugs for those. So let's go back over to our handout. I'll find it eventually. And let's get into our actual drugs and their categories. So we'll start off with this first category, sulfanilamide, sulfonamides, sulfa drugs. These are all going to be categorized together. You can also find them in your chart that starts on page 309. I want to say it's 303 in the previous edition. It's really close to here. Not a big difference there. Sulfonamides are going to be toward the bottom. I'm looking for them right now. They're on page 312. Toward the middle-ish, sulfonamides are there, along with sulfamethoxazole and sulfanilamide. Those are both going to be listed underneath the same category. under drugs that are antimetabolites. So they are very good at inhibiting folic acid synthesis, so they're antimetabolites. That's due to competitive inhibition. Remember when we talked about competitive inhibition? I want to say it was chapter 5 under metabolism. And these are a broad spectrum drug, as we just noticed on page 299. Drug resistance is very common to a lot of your sulfa drugs. There are some allergic reactions as well to sulfa drugs. Sulfa drugs are a great option to people that are allergic to penicillin for things such as MRSA, especially because if you have MRSA, you can use a sulfa drug. However, there are some people that have allergic reactions to sulfa drugs, thus causing another problem for treating MRSA in individuals. We also have a very common drug that we may use and over the counter that's called Bactrim. I shouldn't say over the counter. I am terribly sorry. It's not over the counter at all. Medication. I just completely went the wrong direction with that. Medication that is called Bactrim. A lot of you that are nursing students or you are already out in the field, you may have heard of Bactrim a lot because it's very, very popular, very commonly used. It is what we call a synergist because they are going to be mixed together, two drugs that will actually perform better together. And those two drugs are SMZ, also known as sulfamethoxazole, combined with TMP, also known as trimethoprim. These are great. They work together quite well. It's also very common to use this in horses where you have penicillin allergies, which, yes, that's very common in those as well. And they call it Uniprim for those of you that are in the agricultural industry or been there, and you may know what that is. It's the animal form of Bactrim. There are other synthetics that are also here. Isoniazid. Let me see if I can go ahead and find it in my chart, so that way we're tackling two things at once. Isoniazid, I want to say, is at the front. Let me go through here and find it. It is on page 310, and it's the second one down. It's under drugs that inhibit cell wall synthesis. Isoniazid, like we talked about just a moment ago, is very specific. It's very narrow spectrum. It is very specific to Mycobacterium. Remember, Mycobacterium have a different cell wall than the other types of gram-positive bacteria. And they had the difference of mycolic acid instead of having teichoic acid in their cell wall. So therefore, we have to have something that shuts down mycolic acid production to inhibit their cell wall synthesis. Isoniazid does that. This is great to use in any sort of disease that is caused by a bacterium that is in the genera Mycobacterium, one of which would be tuberculosis. This is used very commonly with ribampin and ethambutol. Let's go ahead and find ribampin. These are very, very specific drugs. Ribampin is the very last one under rifamycins, drugs that inhibit nucleic acid synthesis, on page 313. Ribampin, again, is very specific, very narrow typically, does work against gram-positive bacterium. Trying to think if it's I want to say it's ethambutol. Yes. Ethambutol can cause vision impairment, so that one is pretty strong. I'm trying to think which one, whether it's ethambutol, ribampin, or isoniazid. One of them causes orange urine, and I think whenever we get to ethambutol, it'll talk about it possibly, or ribampin, because they talk about these individually. Let's go ahead and find where ethambutol is in your chart so we can get that knocked out. It is also beside isoniazid because it also inhibits cell wall synthesis. It is very specific to mycobacteria. Another synthetic drug is a quinolone. Now let's go ahead and look those up. Hopefully I'm not getting this too frustrating by looking them up in the chart as we're talking about this. I was hoping that would be better. If it's not, do let me know so I can know in the future to not do something like this. Quinolones are toward the back. Let me find those. Yes, they're on page 313, very top of that page. They are antibacterial drugs that inhibit nucleic acid synthesis. And of those, you have your quinolones, which are represented specifically by mainly Cipro. Okay, Cipro is something that we use quite a lot in a quinolone, and that's the one I have focused on. They block DNA synthesis, so they focus on DNA, a gram-positive and gram-negative bacterium. Fluoroquinolones are very common in this group. We don't really have that in your chart as far as fluoroquinolones, but fluoroquinolones are used to treat UTIs, gonorrhea, chlamydia, GI infections. Cipro is one of those fluoroquinolones. We do have to watch Cipro. You don't want to give it to a child because giving it to children can cause problems with cartilage and bone development. Now let's go to a very large class that is toward the front of your chart. And it is your beta-lactam class. I'm going to go through and tell you the ones that I want you to focus on, and you can go ahead and mark those in your textbook. So you have the beta-lactam class, and under it you'll have your representatives. And I have specific ones I want you to focus on in the textbook, and the others just to ignore. Penicillin G, penicillin V, amoxicillin, methicillin, and then you have your semi-synthetics, carbapenems. Under carbapenems, you have imipenem. Then you have your representative natural cephalosporins. Your semi-synthetic cephalosporins, you want to look at Keflex or cephalexin. And then you have your monobactams that are also representatives of a beta-lactam. You notice this is a huge class with a lot of different types. They inhibit cell wall synthesis. Penicillin G was our first one and most popular. That is an IV actually. Penicillin G is not something that you usually think of whenever you think of the pill form. Penicillin V can be given orally, so it's a little newer. Very useful. We use penicillin V a lot. And now what we use is actually a semi-synthetic, which is amoxicillin. We use that a huge number in a huge number of cases and treatments. Penicillin is bactericidal. There are two common disadvantages of penicillin, one of which is anaphylaxis, which we're very aware of. And then we also have a lot of resistant bacterial species to penicillin, one of which is MRSA. So what is happening here is the interesting thing is bacteria can become resistant to antimicrobials. And what they do is they will create an enzyme that inactivates the antibiotic. And the actual enzyme is known as beta-lactamase. And I have it, I'm trying to circle it here. Hopefully you're seeing my cursor. And whenever we do that, or actually the organism creates beta-lactamase that inactivates the antibiotic. One example of a beta-lactamase is specifically penicillinase right here that will actually inactivate penicillin, the drug. So what we have to do is this really cool thing that a lot of researchers discovered. Hey, we have bacteria that are inactivating the antibiotic. So if I go in here and create something that will override the enzyme that the bacteria are creating, then I can treat with the same antimicrobial. So that's what we've done with what we call augmentin, okay? Augmentin is a mixture of amoxicillin, which is a derivative of penicillin. It's a semi-synthetic penicillin, added to clavulanic acid. Now, clavulanic acid is designed to break down or inactivate the penicillinase that the bacteria are creating that is causing them to be resistant to amoxicillin. So therefore, when we take augmentin, a resistant bacterium to penicillin can still be treated with amoxicillin, because that's what we're doing. Augmentin is a mixture of amoxicillin and clavulanic acid. Hopefully that makes sense to you. Semi-synthetic penicillins, there's a number of different ones that we have. I don't really care that you understand the chains. So this particular chain here that's showing, you can just ignore that. I do not care. Here are your other beta-lactam antibiotics that we just went through. You got cephalosporins. Okay. Cephalosporins are very commonly used nowadays. Especially if you have a penicillin allergy, you may not be have an allergy to cephalosporin, and it's very useful. They do last longer in the body and things of that nature. There's a number of different generations that will treat slightly different types. Keflex is the one I just mentioned a moment ago. Cephalexin is the actual name of it. We call it Keflex more commonly. Rocephin is another one. It's not in your textbook, but it's very common to treat a number of different infections. These don't typically have as many side effects as penicillin do. Monobactams is another beta-lactam, again in that class. Do you notice your major side effects? And I want you to focus on the side effects that are in this particular handout. If there's a side effect in the handout that doesn't show in the textbook, focus on the ones in the handout. Carbapenems, there's imipenem. There's very few side effects to that. A lot of our stuff is made by Streptomyces, which is a bacterium. Another one is vancomycin. Wait. No, that's a different group. I'm sorry. Vancomycin is in a different group. So we've done our beta-lactams. Let me see how long this video is. I'm going to go ahead and stop, and then we'll start the next group, because beta-lactams is your largest group, most intense. Let me go ahead and go through some of these antibacterial drugs that are on these sheets that we've already covered. And I want to go ahead and go through the pages. In your textbook. And I'm sorry, this thing drags terribly. And I'm just looking for the charts. There they are. Okay. Okay, so here's our table 10.2 antibacterial drugs. Let's just go ahead and go through these. And I might actually go through them more than once. I use this chart just because it's going to be a little easier for you to understand. Because if you notice just below your antibacterial handout, there's also an antibacterial chart. I'm wanting you to fill this out. And you'll need to put down your drugs, mode of actions, anything that's clinical consideration, method of resistance, things of that nature. And this is just easier to go through and find your drugs in this handout and then cross-reference. I'm sorry you have to go through and do that, but cross-reference with the handout, because whatever the handout says is going to supersede what's in this text. So the first one is bacitracin. That is one that you need to make sure you have. And as far as this goes, I'm not concerned with the specific inhibition. So like peptidoglycan precursors, I don't care that you know all that. I do want you to make sure that you understand that it is something that inhibits cell wall synthesis in some form or fashion. Okay, this is too much detail for you to be able to remember. I don't expect for you to be able to remember all of that. Route of administration is topical. Very important to know with bacitracin, because if you ingest this, it can be toxic to the kidneys. Okay, there's your adverse effects right there. Your route of administration is topical. Spectrum of action is a gram. It is going to act against gram-positive bacterium. Method of resistance, if there's anything significant about the resistance of these bacterium, you do need to note it. Okay, some of them have some very specific things. Beta-lactams, that's the next class. I have starred penicillin G and penicillin V, amoxicillin, methicillin, your carbapenems, imipenem under that, cephalosporin. If I don't mention the any particular drug underneath it, just the category. Okay. Next one is Keflex, which is cephalexin, and then your monobactams. Ethanbutol, and again, I'm not worried about the details of these things, but it does affect mycolic acid formation, which is something major. Again, your spectrum of actions, your route of administration, your adverse effects, if any, and any major resistance changes. Isoniazid. There's your next one. Vancomycin. Inhibit protein synthesis. So you notice, excuse me, that I just went right past that. These are cell wall. Next one is protein synthesis. Okay, so we're in our next inhibition group. Okay, aminoglycosides, and of those you'll need to know gentamicin. See if I can find it. Gentamycin's right there. Neomycin, right there. Streptomycin, right here. If you notice, this is an older edition of the textbook, so some of you guys might be looking at this going, what? Chloramphenicol, leucosamides, right here, and under leucosamides, clindamycin. Macrolides. Your macrolides, we use these a lot. Azithromycin, clarithromycin, erythromycin. Those are major pharmaceuticals. I'll just put it that way. Still in inhibiting protein synthesis. We have oxazolidinones, and of those, linezolid. Then we're going to skip down to tetracyclines, and of those we have doxycycline and minocycline. Those are used a lot. We're going to skip a couple of these and go to polymyxin. Polymyxin is another one. Polymyxin mixed with bacitracin mixed with neomycin are going to be your triple antibiotic for Neosporin. So that is something very important to remember. What are your 3 medications for your triple antibiotic that is topical? Polymyxin, bacitracin, and neomycin. We're going to skip all the way down to sulfonamides. We have sulfonamides. These are antibacterial drugs that are antimetabolites. And of those, you have sulfamethoxazole and sulfanilamide. The next one to consider is trimethoprim, that we commonly mix with sulfamethoxazole. All right, our next one is quinolones or fluoroquinolones. In here it shows fluoroquinolones. And of those, the first one is Cipro, and we want to focus on ciprofloxacin. Last one is rifampin, that's under rifamycins. Now, again, like I said, I'm not going to cover the antiviral drugs under this section. I cover that when we get to viruses and fungus. So we will not be worrying about the antiviral drugs at this point. All right, so I'm going to go ahead and stop with this section, and then we will cover the rest of it.